What's up, everybody? So we're working today on the C10, the big block C10. This is Daily Driver Big Block C10 for those of you guys that saw our little intro video. But what I'm going to be doing today is I'm going to be making a custom badge for this thing using our little 3-axis sort of hobby grade mill we kind of keep in the shop. And it's a really simple machine. It was designed for garages and stuff, and we use it here for prototyping. We, before we send things out to a machine shop that might have a 2 to 6 week lead time and possibly, $100 to $200 an hour design and program and machining time, we like to prototype in-house so that we know if a press fit tolerance is accurate, or if it's good, if it's going to work, so that we don't have to wait 6 weeks between iterations and spend a ton of money. However, it is a really capable little machine. We've made a bunch of custom stuff around the shop, and I'll show you guys how we do that. And so Phil the other day was like, hey man, you've got a provision here for a badge that's missing. You should try to find that badge. And I was like, well, it's probably the badge that said that this was an inline 6 truck when it was new. So I was like, let's make a 454 emblem. And so I'm going to walk you guys through kind of how I did that. And so the first thing I did was just take the measurements. What I do is I like to measure inside of these holes and then the diameter of the hole, and then add those two together. And what that did was give me the center measurement, because it's really kind of hard to get a super accurate measurement with a set of calipers on center of hole to center of hole. So what you do is measure inside to inside, and then the diameter of the hole, and then when you add them together, that will give you the center and center measurement. So I'll take you guys over to the CAD software real quick. I'll show you the design I came up with. This is the little design that I came up with for the emblem, and I'll show you guys how I did that. I'm using Fusion 360 here. Really simple, easy to use software, and this is a really simple design. Only took me a couple of minutes, and here's how I did it. So initially I threw in my measurements, and what I did was, this is the width of the initial logo, and then the bottom line here, and then I placed the mounting holes that I took the measurement from off of the fender right here, the right distance that I wanted between these two so that they wouldn't crowd, and I would make sure I had some clearance. Then I sort of drew this outer perimeter as my max line. And then I knew I didn't really want it to compete with the actual C10 logo size-wise. So then from there, I kind of just worked down. I created this little block, and I used a simple text command to create the 454, played with a few different fonts, found one I liked, created it here. And then I extruded the base of the badge out first. And this is just simple 1/8" thick extrusion. And I came through and extruded the 454 text itself. And I went through, drew on some more geometry throughout here. The mounting tabs, we came back and fixed that later, so we'll skip past that. But then what I wanted to do was sort of round off any of these corners that could be sharp. And so I used the filleting command to go through and round the corners ever so slightly on some of them. But then what I needed to do was what you just saw, which is these inner corners here and like here and stuff. And the reason why I did that was because I don't like using tools smaller than 1/8" diameter to remove a lot of materials. And tools that are smaller than an 1/8" diameter tend to only have a cut depth of about 1/4 inch. And while that could possibly work for in here, they're very slow, and they tend to break a lot, and they tend to have a characteristic high deflection amount. And deflection is when the tool is actually bending. And given that they're super hard steels like carbide or high-speed steel and stuff, they tend to snap if you bend them, so you have to feed them super slow. And so I didn't think it looked really too much worse to just go ahead and make these corners a 1/16 of an inch. So that's half the diameter of our 1/8" tool, and that allows the 1/8" tool to do all of the work in here that we need. And so we went through, rounded out anything that was less than a 1/16 of an inch diameter, brought it up to 1/16 of an inch, And then we went ahead and sketched on some geometry down here on the bottom side. These are our mounting tabs. Same geometry that we drew on initially, but I made these a little bit larger because I decided eventually to just drill and tap them for I believe it was a 632 screw, and then lowered them down a little bit so that they go all the way through the sheet metal plus a little more. We'll go ahead and use a shim to back that on, or on the back of this to tighten it on. And that way we'll have enough threads, because this whole thing here from here to here is only about 1/4 inch thick. And so if we reduce this anymore, we weren't going to really have a whole lot of threads. So I made it a little longer than it needs to, and then I'll probably put like a sleeve or a shim of some sort to tighten it on the inside of the fender, since we're not really like competing for space back there. But then yeah, filleted these corners around the back side, cleaned up, added a few more fillets here. And that's pretty much the final design there. So the next phase is we came over to the manufacturing side of the house. This is where you do your cam, which is how you tell the machine to do its job. And so we'll start with our 1/4 inch tool. That's going to remove the majority of our material. I like to use the largest tool possible to remove the most material as fast as you can, without really pushing the machine too hard, or you know, you got to find that balance between pushing your machine hard and like time. You don't want to start small using small tools and have this thing take forever. So we're going to start with a 1/4 inch. We're going to remove a bunch of this, but this is what's called roughing for those of you guys that don't know. And so all of these roughing commands will leave several thousandths. It's up to you. You command it, tell it how much you want, and then you come back through with a smaller tool, clear a little more, and then you go into finishing operations, which are a little slower, and they give you a nice surface finish on all of these. So this tool, everything here in setup 2 is actually going to be an 1/8 inch flat end mill. Setup 1 is a 1/4 inch flat end mill. And then so we do this flat command here, and we tell the flat command again, even though this is technically kind of a finishing pass, we're going to tell it to leave a few thousandths, because I want to come in with my 1/8 inch ball end mill, which this is what it will look like before the 1/8 inch ball end mill comes on. And we're going to do some really like decorative tool paths here, because I don't want to paint this. I want it to have that billet look, and I want it to have these really neat tool paths that we can get with operations like the scallop here. So we're going to scallop. That'll give us our fillets around these edges. And then we're going to use this radial tool path here, and this radial tool path is going to give us a nice radius outward. I'll show you guys how that looks when it's all over. All right, so I'm here in front of the mill. This is going to be our little piece of billet. This is 0.63 thick, and it's a little long, so I'm going to throw it in the bandsaw, cut this off, and then inside of here is our new 454 emblem. All right, so I've got the machine set up, got our program loaded, and we're going to go ahead and run that first operation that is the 1/4 inch flat end mill. Then we'll move to our 1/8 inch flat, and then we'll move to our 1/8 inch ball end mill, and then I'll show you guys how it looks after each one of those. All right, so the first operation is done. That's all the 1/4 inch end mill can sort of do. It's cleared out a little bit of these pockets. You can probably barely see it on camera, but the rest is going to have to be done with smaller tools. But I would say that thing looks badass already. All right, our little 1/8 inch end mill is in there, and we're ready to go. All right, the 1/8 inch flat has done its job, and at this point, pretty much 99.5% of the material on this front side has been removed. And now we're gonna come in with the ball end mill and kind of give it a little more. I mean, I think these tool marks look pretty badass as it is, but we're gonna try something a little more wild. and see what happens. All right, the machine is stopped. Let's see what's good. There it is. God, that came out sick. Heck yeah. All right, so the last thing we got to do, put our 1/4 inch end mill back on and get rid of the rest of this material. And then we'll have our 2 studs. We'll do a drilling operation with the CNC. We'll have that drill it out for us, and then we'll do the tapping by hand. All right, now here it is after the 1/4 inch tooling path on this backside. And it's basically done. The next thing we're gonna do is load our drill bit into there. Drill these with the number 21, and then we'll hand tap it for a 1032 hardware, and we'll be done. All right, so we got our number 21 drill bit in. Come over here, probably can't see this, tell this thing. Tool setter, changes the height. We're good. Get rid of this old program. Load our drilling operation. And we'll just confirm that our XY still looks reasonable. It does. And now we'll run this program. So let's get a quick look at it. Still got to drill these fenders out, but that's about where it's going to sit, right there. I think that thing looks great. So, you know, what did this cost, right? The billet that I chose was 12 bucks. It's made in the US, 6061 aluminum, and it was 5/8 bar stock. And I mentioned the dimensions earlier. So I had that for our ARC 4000 cases on hand already, but I bought a bunch of them and they were 12 bucks a piece. I'm sure if you buy only one, it'll probably run you closer to $20. You know, I bought about 3 dozen or something at the time. It took me about an hour to design and set up the tool paths to get the mill to do it. And then probably, you know, I've been kind of farting around in between throughout the day, but probably about 2 hours total machine time, just because that machine is not, I don't push that machine particularly hard. The roughing strategies that I use to remove this on the largest tool, I ran at 40 inches a minute. For example, for you non-machinists, a Haas, like a mini mill or a VF series or a UMC, those can go over 600 inches a minute. So when we go to production with these, if we decide to produce stuff like this and we have it done by one of our machine shops here, they will probably take about 5 minutes. So it's pretty neat, right? Anyways, thanks for watching, guys.